This video looks at stationary points and the values of those stationary points. So there are three types of stationary points: a maximum stationary point, a minimum stationary point, and a point of inflection that is falling in the diagram shown, but you can also have a rising point of inflection where the gradient goes from positive through the stationary point and has a positive gradient on the other side. At stationary points, the gradient, so in functional notation f dash x, or in Leibniz notation dy by dx equals 0. And if the gradient equals 0, then when x equals a, f of a are the coordinates of the stationary point, and f of a is the stationary value. So you can see at all three of these stationary points, the gradient is 0. Now, to find the stationary points and determine their nature, first of all, we need to calculate the derivative of the function of x, so f dash x. For stationary points, we know that the derivative of x equals 0, and so we can equate our derivative to 0 and solve. And then we need to find the coordinates of the stationary points. And the final step is to determine the nature of that stationary point, so whether it's a maximum stationary point, a minimum stationary point, or a point of inflection, rising or falling. And we use a nature table to do that. So in this example, we want to find the stationary point on the curve y equals x squared minus 2x plus 3 and determine its nature. So the first thing we want to do is calculate the derivative of the curve in order to work out what the gradient of that curve is, and that's done by calculating f dash x. So f of x in this example is x squared minus 2x plus 3. And so the derivative of our function of x is 2x minus 2. Now, in order to find the stationary point, we're going to equate that to 0, and then we'd rearrange in order to get x equals 1. So, to find the coordinate of our stationary point, we need to substitute x equals 1 into the original curve to get the value of y. So it's going to be 1 squared minus 2 times 1 plus 3, and that gives us a y value of 2. So we know that the coordinate of our stationary point is going to be 1, 2. Now the final step is to determine the nature. We need to use a table of values or a nature table. So we set it up as x, and we have the numbers going up to 1 and beyond 1. And we need to look at what happens to the derivative of our function and what the slope is going to look like. So at 1, the derivative is 0 and the slope is flat. If we choose a value before 1, for example 0, and substitute that into our derivative, we get a negative value, so a negative gradient. And if we choose a number beyond 1, like 2, we're going to get a positive value for our derivative and a positive gradient. So you can see we have a minimum stationary point at our coordinate 1, 2. Because you can see in the nature table that the gradient goes negative, 0, positive, forming a minimum stationary point. Now in this example, we want to find the stationary points on the curve y equals 2x cubed minus 3x squared minus 12x plus 4 and determine their nature. So the first thing we need to do is calculate the derivative. So f of x is going to be our curve 2x cubed minus 3x squared minus 12x plus 4. And we need to differentiate that. And so f dash x is going to equal 6x squared minus 6x minus 12. And because we know that the gradient of a stationary point is 0, we're going to equate that to 0. Now we're going to factorize it. So we're going to take out the common 6 and divide both sides by 6 to eliminate it. So we end up with x squared minus x minus 2 equals 0. And we can factorize that, and our brackets will be x minus 2 upon x plus 1 equals 0. So you can see that this curve has two stationary points, one when x minus 2 equals 0, so x is going to equal 2, and one when x plus 1 equals 0, so x is going to equal negative 1. So to find the coordinates of those stationary points, we need to substitute in those values to our original curve. So when x equals 2, y is going to equal 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 4. And that gives us a value of 16, take away 12, take away 24, add 4. So y will equal negative 16. And when x equals negative 1, y is going to equal 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 4, giving us negative 2, take away 3, add 12, add 4. So when x equals negative 1, y is going to have a value of 11. So we have two stationary points. One is going to be at 2, negative 16, and the other one is at negative 111. We need to work out what the nature is. We know that f dash x equals 6x squared minus 6x minus 12. So our nature table is going to be any value of x before negative 1, then between negative 1 and 2, and then beyond 2. Remember, you must put your values of x from smallest to biggest. So we need to look at what happens to the derivative. So we know at negative 1 there's a stationary point, and at 2 there's a stationary point, so the gradient is 0 and the slope is flat. So we'll consider a value before negative 1, for example negative 2, and if we substitute that into our f dash x, we're going to end up with a positive value, so we've got a positive gradient on our slope. When we substitute in the value of 0, we're going to get a negative value, so therefore a negative gradient. And if we consider 3, when we substitute that value in, we're going to get a positive value, and so our gradient is going to be positive. So you can see that looking at our nature table, we're going to have a maximum stationary point at the point negative 111, and we're going to have a minimum stationary point at the point 2, negative 16. In this example, we want to find the stationary points on the curve y equals 4x cubed minus x to the power of 4 and determine their nature. So first thing we're going to do is we're going to take our function f of x equals 4x cubed minus x to the power of 4, and we're going to calculate the derivative of that function. So f dash x is going to equal 12x squared minus 4x cubed. And we're going to make that equal 0 because we know that the stationary points have a gradient of 0. Now to solve it, we're going to take out a common 4x squared, and that leaves us with 3 minus x inside our bracket. So we know that 4x squared equals 0. Therefore, x is going to equal 0. And because it's a squared term, it means that it's a tangent at that point. And then we're going to let 3 minus x equal to 0. So our value of x is going to be 3. So now we need to work out our y coordinates by substituting it back into the curve. So y equals 4 times 0 cubed minus 0 to the power of 4 gives us a y coordinate of 0. So it's going through the origin at 0, 0. And we've got y equals 4 times 3 cubed minus 3 to the power of 4. And that gives us a value of y of 27. So we have a stationary point at 327. Now we need to work out the nature of those two stationary points, and we use a nature table to do that. So our stationary points were at 0, 0 and at 327. And our derivative could be expressed in terms of x as f dash x equaled 12 x squared minus 4 x cubed. Now we need to use a nature table to determine the nature of these stationary points. We already know that 0, 0 is going to be a tangent at that point. So we've got any value leading up to 0 and between 0 and 3 and then beyond 0, so that we could inevitably sketch this curve. And we need to consider what happens to the derivative and what the slope of our gradient is going to be like. So we know that at 0 and 3 we have a gradient of 0 and therefore a flat slope. Now we need to consider a value before 0, so we're going to look at -1, and we're going to get a positive value of f dash x, so therefore a positive gradient. If we look at the value of 1, which lies between 0 and 3, we're going to also end up with a positive value, so therefore we have another positive gradient. And then if we consider the value of 4, we're going to end up with a negative value for our f dash x, and therefore a negative gradient. So therefore we have a rising point of inflection at the point 0, 0, so the origin. And then our other stationary point is going to be a maximum stationary point at 327.